Good morning, students. Today we are going to conduct experiment called heat transfer through lagged pipe. Okay. So in this, the aim of the experiment is to find out what will be the thermal conductivity of insulating material. Right. We know that the insulating material will take major part in industries. So we should know what will be the thermal conductivity of the insulating material. Right. So for that purpose, we are going to calculate what will be the heat transfer through lagged film experiment. We are going to find out what will be the thermal conductivity of insulating material. So in this particular experiment, we are using some sawdust as a insulating material. We are going to find out what will be the thermal conductivity of this. So this will be the typical experimental setup for heat transfer through lagged pipe. So this pipe, you can see this will be the two concentric pipes. So inside pipe is fitted with heater. So we are going to provide heating with the help of this dimmer start, and this outer pipe, so that annular space is filled with insulating material. The main, we need to calculate what will be the thermal conductivity rate, right? Means what will be the heat transfer from that heater to that inner surface to that insulating material. Okay, in that way we are going to calculate thermal conductivity of insulating material. So this is the line diagram, what experimental setup we are having here. So you can see this is a concentric pipe here. So inside there will be a heater connection, and at the annular space is filled with insulating material. This annular space is filled with insulating material. So this inner surface temperature we can measure, that is T1, T2, T3, and outer temperature measurement we can take from T4 and T5. Okay. So once you start heating, means if you give some electric power, means electric heating over here, so it will take some 20 to 25 minutes to reach the steady state. Once this system reaches steady state, then take all the readings. You can see this is the multi-channel temperature indicator. Directly we can get all 5 temperatures. This is T4, T5, like that. T1, T2, T3, T4 and T5 temperatures. So this is the with the help of this dimmer start, we are going to vary this heat input to this particular experiment setup. You can see. Now comes to the calculation part of this experiment. So for 50 watt, these are the values, temperature values are tabulated. Okay. First you need to calculate what will be the surface temperature. For that you take mean of 3 surface temperature, T1, T2, T3. So you will get the mean temperature and outer surface temperature. So 2 temperature, T4 and T5 will be the outer temperature, right? Then you take average of that 2, then you will get outer temperature. Right? Then heat input, this is 50 watt. Then thermal conductivity, right? How to calculate thermal conductivity? You know the formula, like heat transfer through the cylinder formula, right? From there you can calculate what will be the thermal conductivity, that is K equal to Q ln R2 by R1 2 pi RL into Ti minus T naught. So substitute the values, you will get the thermal conductivity. Okay. Then how the temperature profile through that insulating material. So here is the formula, Tr equal to Ti minus T naught ln of R by R naught R2 ln of R1 by R2 plus T naught. Okay, outer surface temperature. So this value you can take 25 mm, 30 mm, 35 mm. Okay, for different R value, what will be the temperature? Okay, so then calculate what will be the temperature for 25, 30 and 35. We already know that what is the temperature for 22.5 and 37.5. Okay, you draw temperature profile, radial temperature profile across the cylinder. Okay, thank you.